Hi, I'm Wen from Accton Technology software team. Today I want to introduce our people programmable solutions and use cases. Accton, as a network product manufacturer, we provide all kinds of network devices. Below this, some of our products, including data center DC switches, edge computing, we provide edge servers, campus network, we have enterprise switches, access controllers, and Wi-Fi APs. Telecom products include cell-site gateway, Open RAN RU, and DU servers. We also have many other network solutions. Welcome to visit our website for more information. Below is our list of Accton's people programmable network solutions. Our solutions including from Tofino 1 to Tofino 3 solution switches. We also have server switch that can have powerful CPU in it that can let the switch serve as a server. Tofino 1 we have DCG6700 switch series and DCG7700 server switch series. Tofino 2 solutions are DCG8510 and DCG6710. Tofino 3 solutions are now under planning and will be available in recently. All of our people programmable solution software system will support Sonic. In the further slide, we will provide more detailed information for the spec. First is our Tofino 1 solution, Wedge 100BF. We have two models for Wedge 100BF. One is 32 by 100 gig, and the switching ASIC is Tofino 1 3.2T. The form factor is 1 RU. The other one is 65 by 100 gig with Tofino 1 6.4T with 2 RU high. Next is our Tofino 2 solution, DCG8510. It comes with Tofino 2 12.8T switching ASIC, and the port configuration is 32 by 400 gig. The form factor is 1 RU. Next, introduce our DCG7700 series server switches. It's a Tofino 1 solution and the port configuration is 32 by 100 gig. It has 4 PCIe slots that can let user to insert standard PCIe cards like AI cards, IPU, DPU, or SmartNICs. If user needs to expand the table resource or counter resource, user can also select Accton's FPGA solution for these 4 slots to expand the entry resource to tens of millions of entries. DCG770 also featured with 2 server-grade CPU. We can choose to use Skylake or Cascade Lake CPU based on requirement. That can let this switch serve as a server. With the CPU capability, user can choose to run applications like VN or NFV on our server switches. We also can support 1588 precise timing if customers plan to use this switch in telco environment. One deploy example is shared in 2022's People Workshop event. Alibaba Cloud used the server switch, which is also made by Accton, as the edge server cloud network gateway. Their deploy size is about 300 to 400 server switch in their cloud that can help them to reduce the deploy cost and accelerate their data processing performance. Next, we want to introduce a new open source project called IPTK. We believe IPTK can help our user to simplify the management or application development on our programmable solutions. IPTK is founded by Intel and contributed to the community this year. One of its main purposes is to provide a hardware target agnostic framework and APIs to help the software application to management and offload infrastructure on programmable devices, such as IPU, DPU, FPGA, or Tofino switches. So why do we need IPTK and what it can do? In the past, if we want to develop a software for programmable devices. We have to write a specific driver and rewrite the people program for it based on the target. That means we have to do it every time for each kind of devices. This limits the software's portability and reusability. With IPTK, we only have to use one unified API to communicate with IPTK. Then it will help to take care of the rest of the work to handle with the hardware. That means we only have to develop the software once, then it can be easily to pull and reuse on different devices. This slide shows the detailed design of IPTK. In the middle yellow box, P4OVS provides the northbound interfaces. The orange box, table-driven interface backend, provides the southbound interface. P4OVS provides OVS-DB, P4 runtime, OpenConfig to let remote controllers like SDN or Kubernetes to control P4OVS. After P4OVS receives commands from remote, it will use the TDI interface to communicate with the P4 program to put P4 entries into Tofino or help to create virtual pods. In this slide, we will play a pre-recorded video for demoing IPTK running on our Wedge 100BF. Also, we are now porting IPTK to our server switches. On the left-hand side screen is the IPTK Docker that we built and installed on our device. On the right-hand side is the Linux host. The demo will show how IPTK will help to initial Tofino, and we will try to use people control tool on the host side to send commands into Docker to let IPTK help to set up pipeline.
Hello everyone, I'm John, Wedge team member. In this video, we will have a brief demo for IPTK. We will create Docker named infra P4D by following the building step in the IPTK recipe GitHub. This Docker will be the runtime P4 server in IPTK and configure the forwarding pipeline by runtime P4 client. In this demo, we will show that Docker will listen on the localhost port for runtime client and setting up the pipeline by client's command. We can see the two panes in this window. The left side pane is the Docker infra P4D, and the right side pane is the runtime client. In this demo, the runtime P4 client is the host. As you can see, there is the one Docker named infra P4D. And for the Docker, we run the people runtime Docker with this command. In this command, people runtime will be processed with the different device information and the P4 pipeline configuration. Now we can see the P4 runtime start to initialize. And we will enter BF show. The P4 runtime can set the configuration to the device. As you can see after initialize, you can see this message. The initialize is successful, and the Docker is waiting for master control by listening localhost port. The physical ports in the device are also initialized. And now for the P4 runtime client, we set up the different pipeline configuration in the P4 runtime client with this executable. before runtime control. This executable is created when the application is basically built, and we use this command to check the current pipeline configuration in the runtime before. As you can see, there's no information for a default pipeline complete. And after we compile this command, the Docker will have some communication to retrieve the pipeline information. So now we use this executable runtime before runtime control to set out the forwarding pipeline with given bin file and configuration. As you can see in this command, we give the pipeline, bin file, and the configuration that we prebuilt. So now we process this command. As you can see in the Docker, the given pipeline start to be set up. The message shows the pipeline is set up successfully. So now we check the pipeline information again. So now you can see the pipeline information retrieved, and it will be the same with the given configuration. And for the people runtime control, the executable usage, this other option can use to be configured the pipeline. And for this demo, we use to show the communication between the people runtime client and server in IPDK. This is our brief demo. Thank you.
Next session, we want to share with you about Accton's P4 use cases. First one is the server load balancing accelerator called SLBA. Second is the network test access point tape. The third is the 5G P4 UPF. First, let's take a look about server load balancing. In the middle, we will have a switch to help to forward traffic between servers, and the SLB server will help to distribute user data between backend servers to make the balance of the loading. All the traffic will have to go through SLB server first, then go to backend server. That means higher latency and waste the bandwidth since all have to go through SLB server. And SLB server help to handle the software forwarding that will cause higher CPU loading. With SLBA, we will help to forward the traffic by hardware. You can see after the first traffic go through our device, we will register a P4 entry into Tofino. Then the next traffic will directly forwarded by hardware. That can reduce the CPU loading and reduce the latency for the SLB server. And since Tofino have limited resource, it cannot have a lot of entries in Tofino. We also have an FPGA solution that called XLT, extra large table. It will provide a lot of entry to enlarge the table size of the device. Another use case we have developed is to use the programmable switch as a network test access point device. Our customer require to that they can mirror traffic based on required condition. And also they need basic switching features like ACO. We choose to tailor Sonic to provide customers required features and add pivot into switch.pivot to support tab function. Tab's pivot program will based on users' match action to mirror the flow to targets. In the example picture, user first will configure the tab entry by command. Then we will add a pivot entry into Tofino. For example, flow 1 will flow forward to server A, flow 2 will forward to both server B and C. After configured, if the switch receives flow 1, it will hardware forward by Tofino to server A, and if flow 2 is received, will forward to both server B and C. The last case we want to share is the 5G P4 UPF. The left-hand side is the UE simulator, and on the right-hand side is the data network server. In the middle is our CSP7551 device. In the device, we will install a free 5GC as the 5G core network service. And we develop a pivot program that can let UPF to insert hardware entry to do UPF encapsulate and decapsulate. Let's see how it works. First, the UE will register itself to the 5G core network. The free 5GC UPF will not write an entry into Tofino with two entries, uplink entry and downlink entry. Then if we receive the packet from UE, go into the data network, it will hit the uplink entry and we will decapsulate the GTP header and forward it to the data network server. Then the packet goes back from data network server and enter our device. It will hit the downlink entry. Then the Tofino will help to add the GTP header for the packet, then forward it back to the UE. We also do some tests for the performance of the pivot forwarding. What's the difference between pivot UPF and software UPF? The result is that we can see it is about 100 times greater than the software UPF forwarding. So thank you for watching the video. If you are interested, welcome to contact Accton. Thank you.